Hello and welcome to the Chandara Academy. So we're going to resolve this exercise about the complex numbers. We have three complex numbers here, z1 equal to root 2, z2 equal to minus I root 2, and z3 equal to I root 2. So first, let's find the modulus and the argument of z1 plus z2. So we have z1 plus z2 equal root 2 minus root 2i. Here we have the real part, a, and here b, which is the imaginary part. And we can recognize the algebraic form, z is a plus ib. So, the formula of the modulus is root of a squared plus b squared. Here, the modulus of z1 plus z2 is root of root 2 squared plus minus root 2 squared. This is 2 plus 2 because root square of a equal a. Then we have root 4, which is equal to 2. So the modulus of z1 plus z2 equal 2. For the argument, we know that z on the modulus of z equal cos theta plus ei sin theta. And by identification, we can recognize here a and here b. Here, z1 plus z2 on the modulus of z1 plus z2 is square 2 minus I square 2 on the modulus here 2. We can write it like root 2 on 2 over 2 minus I root 2 over 2. And by identification, here we have cos theta, and here we have sin theta. We can write it like this, cos theta equal root 2 over 2 and sin theta equal root 2 over 2 with the minus. Okay, then we know that the tangent, of theta equal sinus theta on cosinus theta. Here, tangent theta equal minus root 2 over 2 over root 2 over 2 equal minus root 2 over 2 times 2 over root 2. And we know that here root 2 over 2 root 2 equal 1, and also that 2 over 2 equal 1. So we can cross out. And tangent theta equal minus 1. Then to calculate theta, we can use the arctangent of -1 which is equal to minus pi over 4. So this is the argument. C2. Okay, so we have arguments of Z1 plus Z2 equal to minus pi on 4. Okay, so now we're going to do the same with Z1 plus Z3. So Z1 plus Z3 equal root 2 plus I root 2. The modulus of Z1 plus Z3 equal root of root 2 square plus root 2 square. Root 2 square equal 2 plus root 2 square equal 2. So we have the same modulus, which is 2. Then the argument of Z1 plus Z3 equal theta. So we have to find the theta like we did before. Z1 plus Z3 over the modulus of Z1 plus Z3 is root 2 over 2 plus I root 2 over 2. Here the real part A, and here the imaginary part B. We can recognize cosinus theta here and sinus theta. So cosinus theta equal root 2 over 2 and sinus theta equal root 2 over 2. Then the tangent theta equal sinus theta over cosinus theta. Here root 2 over 2 over root 2 over 2. Root 2 over 2 times 2 over root 2. And we can cross out here and here. So tangent theta equal 1. But we want to know theta. So arctangent of 1 equal theta. We can also write that arctangent 1 is tangent power minus 1 of 1. Okay, and arctangent of 1 equal pi over 4. Okay, and this is the arguments of Z1 plus Z3. And the modulus here. For the question B, I'm going to make a little reminder here. So the modulus of Z over Z prime is equal to the modulus of Z over the modulus of Z prime. the modulus of z power n equal the modulus of z power n. We can calculate the modulus and then put the power. For the argument of z over z prime is equal to arg of z minus argument of z prime. Also, the argument of z square is equal to 2 prime arguments, the argument of z. z1 plus z3 over z1 plus z2 square. Okay, the modulus of this equal the modulus of z1 plus z3 over z1 plus z2 square. Here the 2 can be put here. Okay, so this is also equal to z1, the modulus of z1 plus z3 over the modulus of z1 plus z2 square. Okay, we know that the modulus of z1 plus z3 equal 2 and the modulus of z1 plus z2 equal 2. Okay, square, and the modulus of z1 plus z3 2 over 2. 1 square equal 1. Okay, so the argument of z1 plus z3 over z1 plus z2 square equal 1. The argument of z1 plus z3 over z1 plus z2 equal 2 times argument z1 plus z3 over z1 plus z2, which is equal to 2 times argument z1 plus z3 minus 2 arguments z1 plus z2. And we know that the argument of z1 plus z3 equal pi over 4, and the argument of z1 plus z2 equal minus pi over 4. 2 times pi over 4 minus 2 times minus pi over 4. So here we have minus minus, which is equal to plus. So 2 pi over 4 plus 2 pi over 4. We have 4 pi over 4. We can cross out 4 here. So the argument of z1 plus z3 over z1 plus z2 equal pi. Okay, thank you and bye.